Hello, in this video I'm going to talk about some basic principles, basic properties of real numbers that you will need in your algebra class. So basically before you take algebra, this is like beginning algebra. So you will need to know about those properties when solving equations, when combining like terms, doing such things, okay? So this is very important to know those properties I'm going to cover here. So the first one here is commutative property. Now, according to this property, you have to know that if you have two numbers, two real numbers, a and b, so if you do a plus b, you have to know that this is the same thing as b plus a. You should get the same result by doing that. For example, if you have you can pick any number you want. For example, 3 plus 4 must be the same thing as 4 plus 3. And we all know that they're actually the same thing because 3 plus 4 is 7 and 4 plus 3 is 7. So you can switch the values places that should be, you should get the same result, okay? In other words, if you have some variables, let's say if you have for example, this is like example 1. Now 2, if you have x plus 2, you should know that this is the same thing as 2 plus x. The same thing. You get the same result, they have the same value. Okay? So this is called commutative property of addition. Now, how about multiplication? So this works for multiplication as well. For multiplication, if you have, for example, a times b, this should be the same thing as b times a. Okay, so a times b is the same as b times a. And we can take the same example we had previously. 4 times 3 should be the same thing as 3 times 4. You see, you can switch them places, still get the same result. And 4 times 3, is 12. 3 times 4 is 12. So, same thing, right? And the same way, if you have variables, you can have, for example, 7 times x. This should be the same as x times 7, okay? So this could be written as 7x or x7. Should be the same thing. So it's just better or proper to put the numeral before the variable, but it doesn't really matter because they have the same value, okay? So this is commutative property. You should remember this. Now, another property we can cover here is, so this was first, second property here is what we call the associative property. So you have the associative property, okay? So this is the associative property. And again, here you have for addition. So for addition again, what you can have here, what we mean by associative property is that if you have three numbers like a plus b, we're doing addition, so plus b plus c. If we choose, so a plus b plus c, if we choose to associate the first two numbers, the first two values, so a and b, okay, therefore we can actually, this should be the same thing. It should give us the same result when we associate the last two values here. So a plus b plus c, a plus b plus c should be the same thing. So that means you can actually choose to combine like terms whenever you have to combine like terms when you're simplifying expressions, okay? For example, in this case here, if you have, let's say you had 1, let me put example 1 here. Let's say you had 1 plus 2 plus 3, something easier, and 1 plus 2 plus 3, okay? Now, what you have here, you will have to do parenthesis first here, so 3 plus 3 which will give you 6, okay? In this case here, parentheses, so 2 plus 3, which is 5. In this case here, 6, again. You still get the same result, all right? So this is associative property. So it doesn't matter which one you associate, you will still get the same result. Now, this principle will help you when you have, let's say, when you have variables, for example, when you have to combine like terms or simplify something like this, for example, this right here, 10 plus x plus 12, for example, okay? Now, in this case here, since you know the associative property, you will know that this, since you cannot add x and 12 because they're not like terms, you will know that this should be the same when you put the 10, when you choose to associate 10 with 12 instead, okay? And you put the plus x after, okay? This should give you the same as what you had here. Why can you do this? Well, because of the associative property of addition. Okay, in this case, you have 22 plus x, and this is the result here. All right, and you actually you can do this because you're using the associative property again of addition. How about multiplication? Well, it works for multiplication as well, right? It works for multiplication because let's say you have, for example, -3, so I'll call this example 3, and I'll say for multiplication, all right? Multiplication. So for multiplication, let's say you have -3 times 7x, for example. Well, this is the same thing as, and again, you do that just to combine like terms or to simplify whatever you have. In this case, we can multiply. We can choose to multiply the -3, and the 7, and leave the x. It's still the same thing, associative property of multiplication, okay? Now, in this case here, we'll have -3 times 7, which is -21, and x, okay? -21x, okay? This is the associative property of multiplication. So what it means is, what we have is, if you have A times B times C, this is the same, when you associate these two, this is the same as associating the B and the C, or the A and the C, anyhow you want to put it, right? B and the C in this case. So anyhow you want to put it, as long as you associate two different ones, you can still do that. You can still associate two different ones, two different terms, okay? So this is called the associative property of multiplication. Other properties to know would be, let me see, and all those guys will help you when doing algebra. So that will help you understand. And any algebra class you take, even when you get to calculus, you will still need to use those properties of real numbers. So let's say, how about the third one here, distributive property. Distributive property, okay? So distributive property here of multiplication over addition, by the way. Multiplication over addition, what we have here, let me show you. For example, if you have A times X plus Y, okay, this would be the same as, by the way, we said distribute, so we distribute the A to each of the terms here. So this would be A times X plus A times Y. So AX plus AY, okay? We call this distributive property, so we actually distribute the A, distributive property of multiplication over addition, okay? Or multiplication over subtraction, that's how you do it. So, well, how would this work? Let's say you had 7, for example, 7 times 2 plus 4, okay? We all know that to do this, we could have just said okay, this would be 7 times 2 plus 4 is 6. If you use order of operations here, so 6 times 7, 42. So we would say, well, we got the answer here, right? So let's say, how about distributive, using the distributive property? Okay, well, you could have used the distributive property and do this like we just said, right? So you distribute the 7 to the 2, then to the 4. Okay, then you would still get the same answer, because 7 times 2 is 14, plus, let me show you everything here. So 7 times 2 plus 7 times 4, which would be 14 plus, so 7 times 2, 14, 7 times 4, 28. Now when you add them, 14 plus 28 is 42, okay? All right, so still the same thing. This is the distributive property of multiplication over addition. Distributive property, okay? So again, those principles, you use them to reduce, to simplify expressions, when you solve, when solving equations, when doing a lot of different stuff. So commutative property, associative property, distributive property. So you use them for many different things. So another example to show you how good it is to know those properties. Another example, let's take a look at this right here. If we have -5, for example, I'll say -5 times, let's see here, -5 times anything you want to say here, -3 plus 2z, -3 plus 2z. Once you have this, you know it's distributive property here of multiplication over addition or over subtraction. In this case, you distribute the -5. So what it will be is -5, so equal to -5 times the -3 plus -5 times, okay, so I put plus, okay, -5 times, you can write it this way anyhow you want, -5 times 2z, okay? So you're multiplying. Now, -5 times -3 is what? Positive 15. Two negatives give you a positive, so positive 15. Then -5 times positive 2z is negative. Again, here you use the associative property. So -5 times 2, instead you associate the -5 and the 2, which would give you -10, then z. So -10z. And the positive sign here will become a negative. So -10z. Positive times a negative is a negative, okay? So -10z, so 15 minus minus 10z, I'm saying. So 15 minus 10z, okay? So what did we do again? We used the distributive property, okay, of multiplication over addition in this case. So you distribute the -5, and this is what you have. Well, you just simplified this entire thing here. How? By using the distributive property of multiplication over addition, okay? So it's very good to have such skills. And again, if we take another example, it doesn't have to be a binomial, by the way. You may have, it doesn't have to be the multiplication of a monomial and a binomial. It can be a monomial or even a binomial with a trinomial. So in this case, a binomial, 2 times 3x minus 4y minus z, okay? In this case here, again, what do? We distribute. We can use the distributive property, okay? Like this. So it would be 2 times 3x, okay? I'm gonna write everything so everybody could understand here. So 2 times 3x minus 2 times 4y minus, again, 2 times z, okay? So I'm just multiplying 2 by everything, okay? So now what do we have? By the way, you could just do it this way. You don't have to rewrite this. I'm just doing it so everybody could see. So 2 times 3x is 6x 2 times negative 2. So 2 times negative 4y, the same way you're negative 2 times 4y, same thing, would be negative 8y, okay? And 2 times negative z, or negative 2 times z here, is negative 2z. I put the negative sign outside here. It doesn't really matter. You would still, because the 2 was positive, so it doesn't matter. But you can just write it down, and each term, and then you multiply it, okay? So negative 2z. So very easy to do, guys. So 6x minus 8y minus 2z. This is the distributive property, okay? Now, let's look at another one. So imagine you know all those properties, then your algebra class will sound much easier for you. So now, how about this one here? The identity property. So you have, I believe this is number 4. So identities, so identity and inverse, or you can just say, I'm going to show you the identities after, but the property, since I'm just doing properties here. So I'll just say identity, property, and this goes with the inverse as well. So I'll say identity and inverse properties. Okay, because they go really together in this case here. Let me show you. So if we have for the identity, what we have here is, for example, for addition, let me say for addition, one number is actually the identity element for addition, and that number is 0. So 0 is the identity element for addition. Why? Because if we have a plus 0, this is equal to a. Okay, so that's why we call it the identity property. And because of the commutative property, 0 plus a would be the same thing, a. Okay, so that's why we call it the identity property. Now, how about for multiplication? Well, for multiplication, okay, what we know is 1, the number 1. Why? Because a times 1 is equal to a, and 1 times a is equal to a. Okay, so we know that. All right, so this is very important to know. Now, for example, I mean, you guys could take any example you want here in this case. Now, let's say for the first one here, for addition, if you have, for example, 10 plus 0, you know this is 10. And if you have 10 times 1, you know this is 10. So this is identity property of addition and multiplication. Okay. Now the other thing to know is for example, the inverse, additive inverse, what we call additive inverse or opposite. Okay, let me erase this just to show you. So we say additive inverse. For example, let me show you something here. For example, for additive inverse, if you have the number 6, remember we're adding the opposite 6 to it, we know the answer in this case must be 0. Okay, the answer here must be 0. Also, the additive inverse or opposite of negative 5 is 5. Additive inverse, so 3. Additive inverse of negative 5 is 5. Why? Because negative 5 plus 5 is 0. Okay, so this is again inverse property. Okay, which really means we're talking about the opposite in this case here. All right, this is for addition. So if you take the inverse now, for multiplicative inverse, for multiplicative inverse, so this is about additive inverse. Okay, now for multiplicative inverse, you'll have, let's say you have something like this, like 2 over 3. Okay, now 2 over 3, the reciprocal or multiplicative inverse of 2 over 3 is 3 over 2. Why? Because when you multiply them, the answer will be 1. Okay, so if when you multiply you get 1, then you call this the multiplicative inverse. Okay, multiplicative inverse or reciprocals, what we call the reciprocals. Okay, let me put it here so you can. So multiplicative inverse. Okay, so multiplicative inverse. Okay, now it's very, very good to know, because once you multiply here, in this case here, you get 1 as the answer here. Now the same thing for something like this, like having -5 times -1 over 5. Okay, as you can see, this is the reciprocal of that, because this is just like over 1. All right, so you don't need to do anything too complex here, because you know it will be 1, because this is the additive inverse, multiplicative inverse of the other one. Okay, or reciprocal. Okay, so this is very easy to do, guys. Now this is really very important for you guys as you build your strength to get to algebra. So this is very important, beginning algebra. Okay, I think I covered pretty much everything you would need to know in that sense. Okay, so the first thing I saw here was commutative property, then I believe I saw associative property, then distributive property, and identity and inverse property. Okay, so once you know those things, it will be easier for you to solve equations, you know, simplify expressions, you know, doing such things. So this is a very important video that you can use, and it can actually help you when you start taking your algebra classes. All right, thank you.